drops or snowflakes. Maybe so, but certainly not with stars or planets. From our point of view, they're huge and incredibly heavy. However, the latest scientific discoveries have turned these expectations upside down. In space, we've now found amazing worlds that are fluffy like cotton candy or corn puffs. Is this a joke? Have astrophysicists made a mistake? Such planets do exist, and scientists have even designated them as a special group, super puffs, meaning that they are fluffy. They're a kind of exoplanet, space objects outside our solar system, with a mass only a few times larger than our Earth's, with a radius greater than that of Neptune and very low density. Superpuffs look big and massive like Jupiter, but are about 100 times lighter. Their density is less than 0.5 grams per cubic centimeter. That's 0.29 ounces per cubic inch. However, among them are some particularly amazing specimens. The least considered planets, Kepler-51b, 51c, and 51d of the Cygnus constellation. These three exoplanets orbiting the star Kepler-51, discovered in 2012 by the Kepler Space Telescope. Then, 2 years later, they found a strange low-density object. Imagine balls of cotton candy the size of Jupiter. Their density, according to scientists, is less than 0.1 gram per cubic centimeter. That's 0.06 ounces per cubic inch. A piece of this fluffy planet the size of a 160-liter barrel, or 42 gallons, will weigh no more than 16 kilograms, or 35.2 pounds, while a similar barrel of sand will weigh almost 190 kilograms, or 418.8 pounds. But are these calculations correct? It's difficult to imagine the existence of space objects with such a low density. Exoplanets are indeed very difficult to detect and study. They're located extremely far from Earth. Their dim radiation fades in the bright light of nearby stars. To search for such celestial bodies, scientists mainly use various methods of indirect detection, and the results are not always accurate. A careful study of the star WASP-9 with a spectrometer called HARPS, for example, found that in its system there are no planets, as had previously been thought. A similar fate befell the alleged Alpha Centauri b. Repeated analysis of the radial velocity of the star Alpha Centauri b showed that the detected period of its oscillations is due to some nuances of data processing and not the space object itself. But in the case of fluffy planets in the Kepler-51 system, there is no error. This was confirmed by recent research using the Hubble Space Telescope, or HST. Astronomers from the University of Colorado at Boulder studied the atmosphere of Kepler-51b and 51d, hoping to find signs of water on them. They applied the conventional method of transit photometry based on observations of the motion of a celestial body against the background of a star. According to lead researcher Jessica Libby Roberts, no water molecules were found. It also wasn't possible to determine what exactly is occurring in the atmosphere of these cotton giants. The study was hindered by a dense, opaque haze in the upper layers of the gas shell of the planets. In order to clarify the situation, scientists turned to computer simulation. They decided to determine what kind of atmosphere could cause a combination of extremely low density and an opaque shell. It turned out that a mixture of hydrogen and helium surrounded by a layer of methane is best suited to support such conditions. All of these gases are lighter than air. For example, with their help, we inflate balloons. The atmosphere becomes so inflated by these gases that the planets Kepler-51b, c, and d are almost the size of Jupiter, although their mass is only several times the mass of the Earth. Methane also creates a haze that interferes with studying them closely. Astronomers have already observed something similar on Titan, the satellite of Saturn. Due to the thick layer of methane, scientists couldn't get a direct image of the satellite until the arrival of the spacecraft Cassini to Saturn in 2004. Unlike Earth's water clouds, these clouds can also contain salt crystals. They give scientists an understanding of how Kepler-51b and d relate to other low-mass, gas-rich exoplanets. These include, for example, puffy planets. In terms of density, they're comparable to superpuffs. The most rarefied among them, having unusually low pressure, is WASP-17b, with an average density of 0.1 grams per cubic meter, or 0.06 ounces per cubic inch, less than that of foam. It could theoretically float in water without ever drowning if there was a suitably sized pool for it. However, loose planets, unlike superpuffs, are hot Jupiters. They are more massive, located close to their star, and expand under the influence of its energy. Scientists also confirmed the hypothesis that cloud formation is related to the temperature of the planet. The colder it is, the more cloudiness. However, the gas curtain doesn't hide all the secrets of Kepler-51b, 51c, and 51d. These are planets with a very strange pedigree because they simply could not have formed near their stars. But astrophysicists already know a lot about the future of such worlds. Researchers have found that the atmospheres of the planets of the Kepler-51 system are actively evaporating into space. According to them, this phenomenon can explain why superpuffs are so rare. To date, less than 15 of these cotton giants have been discovered by astronomers. Since these strange planets are very young, they're about 500 million years old, the cotton candy-like state could just be a temporary stage of their development. So, scientists suggest that at the end of this space journey, Kepler-51b will become a sort of mini Neptune, the most common type of exoplanet in our galaxy. However, Kepler-51d, which is located farthest from its sun, will remain an unusual planet with a low density, but it will lose significant mass and a small part of its atmosphere. In the very end, though, all the superpuffs will give up, as it were. If these theories are true, they'll help us to learn more about exoplanets. Astronomers place high hopes on the James Webb Space Telescope, or WST, which will replace the Hubble in the year 2021. The device will have high sensitivity to long infrared waves of light and will probably be able to peek through the dense clouds of superlight exoplanets. There are other options. For example, scientists are seriously considering sending nanoprobes driven by solar sails to the distant stars. Tiny spacecraft will take pictures of the planets, study their properties, and transmit the data back to the Earth. With advances in technology, researchers are sure to discover new superpuffs, as well as many more strange worlds. It's estimated that there are more than 100 billion exoplanets in our galaxy. So far, the existence of only a small fraction of these has been reliably confirmed, 4,160 of them to be exact. But what incredible things they keep hidden from us. The inner exoplanet, 55 Cancri E, in the Cancer constellation, can be included among these jewels. Computer modeling conducted in 2011 showed that it consists of graphite and diamonds, a certain amount of carbides and silicates, as well as a large iron core. At the same time, diamonds account for up to 1/3 of the planet's substance. But on HD 189733b, which is 63 light-years from Earth, it rains glass, and in a horizontal direction. Yes, this is not a mistake. The wind on this hellish planet can reach a speed of 8,700 kilometers, or 5,406 miles per hour. So the rains here essentially don't fall down, but to the side. An atmosphere saturated with silicon dioxide causes clouds to spew liquid glass, which falls to the surface of the planet and solidifies. Wind carries glass through the atmosphere at such a speed that the fragments fly horizontally, cutting everything in their path. There are other places in our galaxy and other wonderful worlds where it snows in the form of stones, ion springs erupt, and two suns shine, just like in the fictional world of Tatooine from the movie Star Wars. Just imagine what surprises the huge number of planets that haven't yet been discovered may hold. Why couldn't there be mega superpuffs among them with extremely low density, compared to which the Kepler-51b and d will seem like heavyweights? Do you think this is possible? Tell us in the comments below. If you like this video, give it a thumbs up, subscribe to the channel, and click on the bell so as not to miss out on new releases. And recommend us to your friends. It's more fun together. Until next time.